The Saab 340 is a twin-engine turboprop aircraft designed by Saab AB and Fairchild Aircraft. Saab began development of its first major civilian aircraft in 1974 and determined that a short-haul airliner should be optimised to seat around 30 passengers using an economical turboprop power plant. The engine selected was the General Electric CT7 5A2, which was competitive in the short-haul role with the jet engines in service at that time. When it was introduced in 1984, the Saab 340 became the best-selling commuter aircraft in the world, with 460 delivered when production was terminated in 1999. In 2002, Field Aviation were contracted by Saab to produce a freighter version of the 340, and in 2006, as the demand for turboprop-powered airliners increased, Saab leased 25 340s to the Australian operator Regional Express Airlines. We start by planning the fuel load required for the flight. The departure airport is Southampton and the arrival airport, Jersey, a flight distance of 180 nautical miles. Cruise altitude will be 21,000 feet. ECS is on, engine anti-ice off, and we will be using maximum cruise power with propeller RPM between 1,250 and 1,330. Payload weight is 7,527 pounds. Conditions are ISA with a barometric pressure of 29.92 inches of mercury. The flight will take approximately 50 minutes and 866 pounds of fuel is required. We require an additional £10 for engine start, £8 for taxiing, and £50 for 3 minutes additional time for a full procedure. The fuel reserve will be £1,000. Total fuel required for the flight is £2,006. Open the ground equipment window and remove the pitot covers, flags, and main wheel chocks. Left and right AC generators on. The left and right AC generator switches control AC generator power supply. In the on position, the AC generator is online. In the load transfer position, power is transferred from the other side with intake heat supplied by its own generator. In the off reset position, power is transferred from the other side with no intake heat. The left and right AC generator lights illuminate if the respective generator is not supplying power. Left and right avionic off. Essential avionic off. Bus tie automatic. Left and right generators off. Temperature control set as desired. The temperature control unit regulates temperature between 18 and 29 degrees Celsius or 65 and 85 degrees Fahrenheit. Temperature select automatic. The left and right temperature select switches have three positions: automatic, hot/cold, and neutral. In the automatic position, temperature is automatically regulated at the level selected with the temperature selector. The hot/cold position is spring-loaded. The temperature control valve moves in the desired direction. This position should only be used if automatic temperature regulation fails. No temperature regulation is provided in the neutral position. The left and right batteries are powering the left and right hot battery buses respectively. The left hot battery bus powers dome, entrance, and cargo lights. The right hot battery bus powers refueling and defueling. Dome lighting is particularly important when starting the aircraft in low light conditions. The DC amp/volt indicator indicates the voltage for the selected bus or source. To view left and right battery DC source voltage, rotate the amp/volt selector. Battery requirement is minimum 24 volts. Left battery on. The start bus receives power. The left generator bus distributes power to the cabin recirculation fan and hydraulic pump power. The left battery bus is powered via the left generator bus. It distributes power to various systems, including left engine start control, auto ignition, and its generator control unit. The battery bus powers the left essential bus, which distributes power to the left fuel quantity, left propeller speed, left auto caution system, and left essential bus voltage indication. The emergency bus is also powered, distributing power to systems including left and right engine fire detection. Right battery on. The right generator bus receives power and distributes power to the cockpit recirculation fan. The right battery bus is powered via the right generator bus, which distributes power to various systems, including right engine start control, auto ignition, and its generator control unit. The battery bus powers the right essential bus, which distributes power to the left and right battery and fuel temperature indication, the fuel crossfeed valve, right fuel quantity, hydraulic quantity indication, standby pitot heat, right propeller speed, right auto caution system, and right essential bus voltage indication. Left and right battery hot lights, check out. The battery hot lights illuminate when the respective battery overheats. If the battery exceeds 71 Celsius, the battery relay opens, disconnecting it from the start bus and its respective generator bus. The emergency power light is illuminated if the emergency power bus is not powered, or if the emergency power supply voltage drops below 24 volts. Bus tie connected green light, checked on. When the bus tie switch is in the automatic position and batteries are on and one or both generators are not working, the bus tie relay is energized and the left and right generator buses are connected. The bus tie light must be on before all engine starts. The top half of the lights on the central warning panel are red warning annunciator lights. The bottom half of the lights are amber caution annunciator lights. A red warning light indicates immediate action is required. An amber caution light indicates corrective action or close attention. Warnings always take priority over cautions. Some caution lights include an arrow. The arrow points in the direction where the indicators and the controls for the particular system are located. When one or more of the red warning annunciator lights on the CWP are illuminated, the master warning light illuminates, and the triple chime activates. The system can be reset by pushing the master warning button light. When one or more of the amber caution annunciator lights are illuminated, the master caution light illuminates and the single chime activates. The system can be reset by pushing the master caution button light. The annunciators remain on until the fault is corrected. Note that if the config warning light is illuminated, pitch trim tabs are out of takeoff range, condition levers are not in the maximum position, or flaps are not in the takeoff position. Landing gear handle, down. Check that the handle is engaged in the down detent. Landing gear lights, checked. Check that the three green landing gear down and locked lights are illuminated. Press the test button to check the transit light. With the gear locked in the down position, the amber internal gear handle disagreement light illuminates, indicating the integrity of the lamp and the already activated landing gear lights. Hydraulic pressure, checked. Check outboard and inboard brake accumulator pressure. Essential avionic, on. The essential avionic bus is now connected to the left essential bus, distributing power to VOR/ILS/marker 1, VOR/ILS indicator, and ATC transponder 1. And the emergency avionic bus is connected to the emergency bus, powering VHF COM 1 and standby horizon. Main inverter, on. In the on position, the main inverter supplies 115 volts AC to the left and right inverter bus 115 volts AC, and 26 volts AC to the left and right inverter bus 26 volts AC. If the 26 volts main standby inverter switch is in the main position. The main inverter light will remain illuminated until the left main bus is powered. 26 volts, main inverter. Cross valve, off. When set to on, the crossfeed valve opens and the crossfeed light illuminates. The crossfeed line connects the fuel lines feeding each tank with its respective engine. Pneumatic power is used to operate air conditioning, pressurization, and boot de-icing. Engines supply high and low pressure air to the pneumatic system. High pressure bleed air is automatically supplied whenever low pressure bleed is not sufficient. High pressure air is bled from a point behind the 6th or radial compressor stage. It has 3 times greater pressure than low pressure air bled off behind the 5th compressor stage. HP air is only supplied if gas generator speed is below approximately 80% NG. Bleed valves, reset/auto. The reset position is used to reset a closed valve. In the automatic position, bleed air pressure is regulated as a function of altitude. The bleed valve closes if bleed air temperature is too high, fire handle is pulled, regulated pressure is too high, air conditioning pack compressed discharge temperature is too high, or distribution duct temperature is too high. HP valves closed. The HP valve switches have three positions: reset, automatic, and closed. In the reset position, a closed valve is reset if a closed signal is no longer present. In the automatic position, the valve is opened and closed according to high pressure bleed demand. The HP valve closes if bleed air temperature is too high or the fire handle is pulled. In the closed position, the valve is closed. HP bleed may be necessary to check the boat de-ice system or for cabin comfort in hot or cold conditions. If not required, the HP valves should be in the closed position to prevent a significant rise in ITT, especially with the power levers at ground idle. Beacon on. Cabin signs on. Fuel quantity checked. Hydraulic pump automatic. Air conditioning is provided by two packs located under the cabin floor in the wing fairing. Bleed air from the pneumatic system is compressed and cooled by an air cycle machine and a dual heat exchanger. The cooled air is then mixed with hot, bypassed air and with air from the recirculation fan. The recirculation fans return air from the cockpit and cabin back to the respective pack to improve airflow. Conditioned air from the left pack is distributed to the cabin and from the right unit to the cockpit and cabin. The distribution systems can be connected on the ground through a cross valve. The cabin is pressurized by the air conditioning packs. One pack is sufficient for pressurization up to 31,000 feet. Cabin pressure is controlled automatically by a pressurization controller, or manually with a control valve located on the cabin pressure control panel. Cabin pressure set. The mode selector has two positions: automatic and manual. In the automatic position, the pressure controller operates automatically according to its own cabin pressure schedule. In the manual position, cabin pressure is manually regulated with the manual pressurization knob. The cabin rate set knob is in the indicated detent position. The detent position corresponds to a 500 feet per minute climb or a 300 feet per minute descent. To set the landing airfield altitude on the landing altitude barometric indicator, use the altitude set knob. To set landing airfield barometric pressure in inches of mercury, use the barometric set knob. Radar/transponder standby. To avoid fuel flow fluctuations during battery start due to voltage variations, it's recommended to perform a battery start on the right engine and a crossover start on the left engine. power levers, ground idle. Because the power lever control axis includes the alpha and beta ranges, it's important to place the controller axis in the ground idle position. The power levers serve as power demand input to the HMU. The HMU provides high pressure metered fuel for combustion. Fuel output from the HMU is indicated on the fuel flow indicator. In the range aft of the flight idle position, the power levers also control propeller pitch for ground operation, including reverse. Right condition lever, start. In the start position, the fuel shutoff valve in the HMU is opened, allowing ignition when the starter is activated. When the left/right relay is closed, the starter/generator receives power from the start bus. When using batteries for engine start, the batteries are connected in series, the left generator bus is separated from the start bus, and 48 volts DC is supplied to the starter/generator. The relay has a hold function and will remain closed when the start switch is released. Engine start, right. Check power plant parameters during acceleration to ground idle. ITT rises, followed by a rise in NG and NP. The right engine oil pressure warning annunciator extinguishes. Light up occurs when the fuel is ignited and the fire in the combustion section is fed by air from the compressor section. The left/right relay opens at 55% NG, controlled by the GCU, and at starter/generator cutout, the right ignition light extinguishes. Propeller rotation is now above 200 RPM. When the engine instruments are stable, the main pump lights illuminate if respective main pump pressure is low. The right main pump light is now extinguished. Check that the bus tie connected light is on before turning on the generator. If the light does not illuminate, check battery voltage. If voltage is below 20 volts, turn the battery switches off and shut down the engines. Right generator, reset, on. The right generator relay is closed and the starter/generator powers the generator bus. The right main start bus relay is closed, connecting it to its battery bus. The right generator light extinguishes because the right generator relay is now energized. Emergency power light, check out. The emergency power bus is now powered with a minimum of 24 volts. The left and right main bus lights are extinguished as the main bus relays are closed and the buses are connected to their respective generator buses. The left generator bus is powered by the right generator through the bus tie relay. The right generator light extinguishes because the right generator relay is now energized. The main inverter light extinguishes because the left main bus is now powered. The utility bus is also powered. The buses distribute power to various items including the left main bus, the left landing light, navigation lights, propeller synchro phasing, main inverter 115 volts 26 volts, and left main bus voltage indicator. The left main start bus, instrument lighting left, centre, and centre pedestal. The right main bus, cabin temperature control, right landing light, strobe light, standby inverter 26 volts, and right main bus voltage indication. The right main start bus, instrument lighting right, and the utility bus, cabin attendant call buttons. Left and right avionic, on. Wait approximately 70 seconds for initialization. The bleed closed light is illuminated because the bleed valve is closed. The associated master caution light is also illuminated. Right bleed valve, as required. Right HP valve, as required. When avionic initialization is complete, left and right avionic, off. We will now perform a crossover start on the left engine. A crossover start is performed on batteries and one generator. Left condition lever, start. Engine start, left. When the engine instruments are stable, nav on. Left generator, reset, on. The left generator relay is closed and the starter/generator powers the generator bus. The left main start bus relay is closed, connecting it to its battery bus. The left generator light extinguishes because the left generator relay is now energized. Left bleed valve, as required. Left HP valve, as required. Hydraulics, checked. Hydraulic power is used to operate the following systems: flaps, landing gear, brakes, nose wheel steering, and propeller brake. An electrically driven pump supplies hydraulic pressure to 4 accumulators. The pump is controlled with the hydraulic pump switch on the hydraulic panel. The hydraulic pump switch has 3 positions: override, automatic, and off. In the override position, the pump runs continuously. In the automatic position, the pump operates during the following conditions: if main hydraulic pressure falls below 2100 psi and until pressure reaches 2900 psi, during landing gear extension or retraction, or when the right propeller brake switch is on. In the off position, no electrical power is supplied to the pump. The hydraulic quantity indicator indicates fluid quantity in the main reservoir. The hydraulic pressure indicators indicate hydraulic pressure in the main system, emergency accumulator, and the outboard and inboard brake accumulators. Standby pitot, on. In this position, the standby pitot tube is powered. Ice protection, set, checked. The aircraft is fully equipped for all-weather operation. Icing conditions exist when OAT on the ground and for takeoff or SAT in flight is 5C or below, and visible moisture, clouds, fog with visibility of 1 mile or less, rain, snow, sleet, or ice crystals is present. All systems are controlled from the overhead panel, except for the main pitot tubes, temperature probe, and angle of attack sensors. which are powered automatically when an AC generator is online. To apply regulated electrical power to heat the left and right side and front windshield, set the respective switch to the normal or high positions. The normal position is used for defogging and high for de-icing. Normal must be used for 7 minutes before high is selected. The left and right side and left and right front lights illuminate when an overhead or controller fault occurs. To initiate heating cycles for each pair of symmetrical propeller blades, set the left and right propeller de-ice switches. The switches have 3 positions: off, normal, and maximum. In the normal position, the heating cycles power on for 11 seconds and off for 79 seconds. In the maximum position, the heating cycles power on and off for 90 seconds. The left and right propeller lights illuminate when a fault is detected in an activated system. The left and right engine anti-ice switches control electrical and bleed air sections of the engine anti-ice system. To prevent FOD, it is important to switch on engine anti-ice well in advance of entering icing conditions. The left and right intake lights illuminate if a failure in the engine duct electrical anti-icing system occurs. The left and right air lights illuminate if the electrical solenoid valve does not open when the respective engine anti-ice switch is turned on, or if the valve does not close when the switch is turned off. The auto cycling switch has 3 positions: off, continuous, and 1 cycle. In the continuous and 1 cycle positions, a timer is activated to perform a 4 times 6-second boot inflation cycle in the following order: stabilizer, outboard wing, inboard wing, and stabilizer. In the continuous position, 1 cycle is completed every 3rd minute. In the 1 cycle position, 1 cycle is completed. The timer light illuminates if the boots are not cycling. With the auto cycling switch in the continuous position, pressure remains on in the stabilizer boot zones. With the auto cycling switch in the 1 cycle position, pressure remains on in the stabilizer boot zones when the next cycle is activated, or pressure remains on in the left and right inboard wing or left and right outboard wing boot zone after more than 8 seconds. The boot indication lights illuminate whenever the respective boot system is pressurized and the boot indication switch is in the on position. The manual de-ice buttons override in the timer function and keep the respective de-ice valves open while the button is depressed. The de-ice overheat temp light illuminates whenever either of the 2 overheat sensors detect an overtemperature. The associated master caution light also illuminates. The air supply switch has 2 positions. In the on position, shut-off valves are open. In the off position, shut-off valves are closed. Auto caution on. In the on position, the propeller of a failed engine is automatically cautioned to a minimum drag setting, without being completely feathered. Left and right avionic on. The left and right avionic buses and left and right avionic start buses are now powered and distribute power to various systems including left avionic bus, flight director and MSP, autopilot controls and servos, ADF1, DME1, radio altimeter, AHRS1 main power, and left avionic bus voltage indication. Left avionic start bus, VSI or VNI and altitude preselector, and EFIS1. Right avionic bus, flight director and MSP, autopilot controls and servos, VHF-COM2, ADF2, DME2, weather radar power, AHRS2 main power, and right avionic bus voltage indication. Right avionic start bus, EFIS2, bus tie, checked. With both generators working, the left and right generator buses are not connected. Air conditioning panel set, checked. Check all caution lights are off. The left and right bleed closed lights illuminate if the bleeds are closed. The left and right duct overheat temperature lights illuminate if there is an ACP compressor discharge over temp or redistribution duct over temp. The left and right recirculation lights illuminate if the respective recirculation fan fails. The left and right bleed air leak lights illuminate if a hot air leak is detected. Recirculation fans as desired. The recirculation fans feed air from the cockpit and cabin back to the respective pack to improve airflow. Emergency lights armed. The emergency lights must be armed whenever the aircraft is moving under its own power and are activated if there is a loss of power to the right main bus. The lights are powered by 5 NiCad batteries located under the cabin floor. Trims set. The trim indicator displays trim tab deflection for pitch, roll and yaw. The green band indicates the takeoff range. When flaps are at the takeoff position in the 0 to 15 degrees range, pitch trim in the normal takeoff range, and the condition levers set for maximum propeller RPM, the aircraft is configured for takeoff. Fuel used, reset. Navigation set. Autopilot set. The F-gas includes a flight control computer which includes a flight director/autopilot. The FCC interfaces with various aircraft systems including the ADS, AHRS, navigation radios, EFIS, and the altitude preselect/alert system. The FCC functions are controlled by the MSP, APP, and the autopilot disengage buttons. The FCC provides steering command signals for control of flight path during all normal phases of flight. FCC signals are fed to the FD command bars and symbols on the EADI. The FD provides visual guidance commands to fly the aircraft manually or to monitor the AP response to guidance commands. The guidance commands are selected with the FD operating mode push buttons on the MSP. Pitch and roll guidance cues and mode information are displayed on the EADIs. The AP controls the aircraft in pitch and roll axes on commands from the FD. The yaw damper is part of the AP rudder steer channel and provides directional stability. Captured modes are enunciated on the EADIs in green text. Armed modes are enunciated in white text. When a mode is changed, the new mode enunciation blinks for 5 seconds. The following modes are available. The vertical modes are vertical speed. The FCC provides pitch attitude commands to maintain the vertical speed existing when the mode was engaged. A new vertical speed reference can be selected with the pitch knob on the APP. Indicated airspeed. The FCC provides pitch attitude commands to maintain the IAS existing when the mode was engaged. To change the IAS, turn the IAS bug knob. Climb. The FCC computes and updates a climb IAS displayed on the EADI. Climb mode has 3 rate of climb settings, which correspond to their effect on IAS: high, medium, and low. The high setting gives a low rate of climb, medium a medium rate of climb, and low the best rate of climb. Altitude. The FCC holds the altitude existing when the mode was engaged. Lateral modes. Heading. The FCC provides commands to turn to and hold the heading indicated by the heading bug on the EHSI. The turn is in the direction of the shortest arc. The heading bug can be moved manually with either the heading knob on the CHP or by the turn knob on the APP. Navigation. The FCC commands capture and tracking of the course defined by the active navigational data, displayed on the EFIS. Combined mode. Approach. The FCC functions in principle as in navigation mode, but commands are also given for vertical capture and tracking if an ILS glide slope is available. The FD display can be deactivated by pushing the FD button on the DCP, except for when using approach mode, when the FD bar is always displayed. The AP/YD engage levers on the APP allow independent yaw damper engagement. When the autopilot is engaged, the yaw damper is also engaged. Set the desired altitude with the altitude select knob. Southampton has certain noise abatement procedures. As the Saab 340 has an MTOW of 13,063 kg, we must follow the procedures. As soon as possible after passing 500 feet altitude, turn right to intercept VOR SAM radial 217. Maintain radial 217 until 2000 feet altitude. We tune nav 1 to the Southampton VOR, which is 113.35. And set a course of 217 degrees. We set the heading bug to runway heading. The heading bug can be adjusted with the heading knob or the turn knob. Check that NG and NP are stable. Open the ground equipment window and remove the nose wheel chocks. External lights set. Power levers, ground idle, condition levers, minimum. Note that normally the unfeather position is used for transit only. Check NG and propeller RPM. The propeller starts to unfeather and propeller RPM increases. NG should accelerate slightly as propeller RPM passes 830 and stabilizes at 1040. The bottoming governor automatically provides a minimum propeller RPM during ground operation, 1040 during normal ground operation, and 1200 during full reverse thrust operation. Wait for the engines to stabilize. The left and right AC generator lights are extinguished because the AC generators are supplying power. The left and right pitot lights are extinguished because the main pitot tubes are powered. The left and right alpha lights are extinguished because the angle of attack sensors are powered. Condition levers, maximum. The maximum position in the propeller constant speed operation range is 1396 RPM. Beta lights, check on. The beta lights indicate that the power levers are in the beta operating range. Ice protection, as required. We are now ready to taxi to the active runway. As always, feel free to like, comment and subscribe.